Hello, welcome to Zigmatech Learning Hub. I'll be your instructor for geography. For this class, we are going to be taking our exercises from the ExamGuide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. ExamGuide is a leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, BECE, JSCE, NCEE, NECO, etc. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. So, in today's lesson, we are going to continue from where we stopped. That's longitude and latitude. And we are going to look at the differences between latitude and longitude. Then we'll also look at the similarities we have between latitude and longitude and the importance or relevance of latitude and longitude. And then we're also going to look at great circles, and we'll also look at grid system of locating objects. And then we'll finally look at terminologies like international dateline, local time, and standard time. So let's head right in. So previously I said lines of longitude, they are actually imaginary lines running from the North Pole to the South Pole, and they are measured east and west of the Greenwich meridian. Why lines of longitude are simply angular distances, north and south of the equator. So let's look at the differences we have between latitude and longitude. So the first difference is that the lines of longitude, they actually run from the north to the south, whereas the lines of latitude, they run from east to west. Then the second difference we have between latitude and longitude is that longitude on its own are called meridians, while the lines of latitude are actually called parallels. Now, this is to say that the lines of latitude are actually running parallel to each other. That means they don't meet. But for the lines of longitude, which are actually called meridians, they actually converge at the north and south pole. And also, we use the lines of longitude for calculating local time of places. But for the lines of longitude, they are not used for calculating local time. Instead, they are actually used for calculating the distance of a particular place. And lines of longitude are not specifically used for calculating distances. Now, the next difference we have between longitude and latitude is that the lines of longitude, they all have the same length. Now, that's to say that they are all equal in length. But if you look at the lines of latitude, as you head towards the North Pole or the South Pole, you discover that the length of the lines become smaller and smaller and smaller till you get to the North Pole. So they get shorter in terms of, not just in terms of length, but they also get shorter in terms of radius and diameter. And also, considering great circles, all the lines of longitude are great circle, but the lines of latitude, only the equator can be seen as a great circle. So every line running from the North Pole to the South Pole, meeting up with the opposite line, actually form a great circle. But when you look at the lines of latitude, it's just only the equator that that divides the Earth into a 2 equal half, and is the longest of all of them. So the next difference is that lines of longitude, they have a value of 180 degrees, but the lines of longitude, the highest value you can get is 90 degrees. That means for lines of longitude, we have 180 degrees east and 180 degrees west while you're going around the globe. But for lines of latitude, as you head towards the North Pole or the South Pole, the highest angle or value you can get is 90 degrees. So let's look at the similarities between latitude and longitude. Now, the first similarity we have, between latitude and longitude is that they are imaginary lines. They are actually lines that are imagined. They are not just there. They are not there on the equator, and so we call them imaginary lines. Let's also look at the second similarity. Now, for both of them, they actually combined to, make the grid system of the Earth. So what I'm trying to say is that we have what they call grid lines, and grid lines are actually used, to pinpoint or to get the precise location of a place. So we make use of latitude and longitude combined together to, to form a grid line. And whenever we are actually looking for a particular location on the Earth's surface, we make reference to both the latitude and longitude. What I'm trying to say is this, that you cannot find a place on the Earth without combining both latitude and longitude. Let's take, for instance, the location of Nigeria. Now, if you are to search for Nigeria on the globe, Nigeria is actually located between latitude 4 and 14 of the 4 and 14 degrees north of the equator, and longitude 3 and 15 degrees east, both east of the Greenwich meridian. That's to say that if I make use of only the latitude and leave the longitude behind, then that country is no longer a land area. It's possibly what? A straight line, or or any type of line we have. So that's what we use them for. And also, latitude is an angular distance, longitude is also an angular distance, and they are both measured in degrees. We measure the lines of latitude based on degree north and degree south, while the lines of longitude are measured based on degree east and degree west. And they both contain great circles. That is, great circles are actually circles that divide the Earth into two equal halves, or whose plane cuts the Earth into two equal halves. Now, they are also seen as what? As unique lines drawn on the Earth's surface. Though we have other unique lines that are actually drawn on the Earth's surface, like isobar, isotherm, and the rest, the lines of latitude and longitude are also what? Unique lines that are drawn on the Earth's surface. So these are the, the similarities we have between latitude and longitude. So let's look at the importance of latitude and importance of latitude first. Then we'll also look at the importance of longitude. Now, for latitude, we use it to identify or locate heat zones on the Earth. That's one relevance of latitude. Whenever we are actually finding the heat zones, different heat zones we have on the Earth's surface, we actually make use of the line of latitude. And also, we use the line of latitude to measure the distance, between the north and the south, from the equator. So if we are to calculate the distance of any place on the north or any place on the south with reference to the equator, we make use of the lines of latitude. Then we also use latitude to understand how wind circulates on the Earth's surface. Mind you, remember I told you that the lines of latitude are actually lines running from the east to west, and it moves whenever the Earth is rotating. So whenever the Earth is actually spinning on its axis, the lines of latitude will help us to understand how wind is being circulated around the Earth whilst rotation is going on. And also, we use the line of latitude to help us find the distance of any place away from the equator, and it's always based on the degree of latitude. So if you're being given a particular location, let's say X, and you're given the latitude, with the help of this latitude that is being given to you, you can actually find the distance of that place from the equator, which is latitude 0. And also, we combine latitude with longitude to find the location of a place or the position of a place. And these coordinates are actually called the Global Positioning System, that is GPS, and it's found in almost every modern day phones we have in the world today. So let's look at more relevance or importance of longitude. The next one we have is that we use longitude to calculate local time of a place. Remember I said we are looking at the importance of latitude and longitude. So for longitude, we use it for calculating the local time of a place. Then we also combine longitude with latitude to find the location of a place. And whenever we want to measure a distance from the Greenwich meridian, we make use of the lines of longitude. And lines of longitude and latitude, they help us to measure the distance from the equator mathematically. So let's head over to great circles. Remember previously I said both lines of latitude and longitude contain great circles. Now, what are great circles? Great circles are actually imaginary circles on the earth. Imaginary circles on the earth whose plane passes through the center of the earth. And when such plane passes through the center of the earth, it actually divides the earth into two equal halves or two equal hemispheres. So what I'm trying to say is that any imaginary line you draw on the earth that can divide the earth into two equal hemispheres, be it horizontally or vertically, such line is seen as a great circle. And any circle that cannot do such, that cannot divide the earth into two equal halves, is seen as a small circle. So the opposite of great circles are what? Are small circles. Like the Tropic of Cancer, the Tropic of Capricorn, the Antarctic Circle, and the Arctic Circle. These are examples of small circles. Now, for great circles, the radius or the midpoint of every great circle gives us the center of the earth. The midpoint of every great circle, be it the equator or be it the meridians of the lines of longitude, they actually have a midpoint, which is the center of the earth. And take note that only the equator for lines of latitude is a great circle. So let's look at examples like we have now. Examples of great circles for lines of latitude, we only have latitude 0, which is the equator. Then for lines of longitude, I would say every complementary angle of longitude is actually a great circle. Now let's look at longitude 0. The complement of it is going to be longitude 180 degrees. So longitude 0 and 180 degrees, either east or west, is actually a great circle. Then we also have 20 degrees east and 160 degrees west. Those two lines are actually great circles because they combine together to give a full circle that divides the earth into two equal halves. Then we can also have other examples like longitude 140 degrees east and longitude 40 degrees west. It's also an example of great circles. So the list go on and on and on and on and on till we exhaust all the angles of longitude. Now, this is an illustration of what a great circle is, as you can see on the screen. Now, if you look on the screen, we have what? We have 0 degrees, and we also have 30, 60, 90. Now, 30, 60, 90 are actually called small circles because when you measure them, their midpoint or radius is not going to be at the center of the earth. But for the equator we have here, it's at the midpoint of the earth, and it goes around to divide the earth into two equal halves. So the equator is just an example of a great circle we have here. Then for the lines of longitude which we have here, starting from the prime meridian to other meridians we have around, they are all what? They are all great circles. Let's look at this. For instance, we have 180 and 0 here. It's a great circle. We have 150 on the negative side, which is the west, and 30 on the positive side, which is the east. That is also a great circle. We have minus 60 on the negative side, which is the west, and we have 120 on the positive side, which is the east. So this 60 and 120 here is actually a great circle. So these are examples of great circles we have on the globe. So let's look at the importance of great circle. Why are great circles very important? Now, one thing about great circle is that in the aviation sector, they actually make use of it for navigation flight. And what's the reason for that? The reason for that is that great circles actually give the shortest distance between 2 points on the Earth's surface. So as a result of that, people in the organizations in the aviation sector, they actually make use of grade circles or travel through grade circles just to save time and to save fuel. And also, air routes of the world, and not just air routes though, we also have ocean routes too. They actually make use of grade circle to save time. So just as the pilots, they make use of grade circles, people in the seaports or the river ports, that is these sailors, they also use grade circles to save time too. So that's actually the importance or relevance of grade circles. So let's look at the disadvantages of grade circles. Now, when you follow through a grade circle, it does not actually guarantee your survival. So the grade circle is not all grade circles are actually ideal to travel through, because in times of rescue, it will be very difficult or very hard to be rescued. So sometimes they actually make use of the longer routes. And in terms of security, some countries restrict flights and navigation over their territories. Let's say, for instance, passing through Moscow, just an illustration. Maybe passing through Moscow is actually a grade circle. The government of Moscow might decide to restrict flights from other countries, going through their air route. So they will try to prevent people from using it for free. So this is also a disadvantage we have when it comes to grade circle. And the grade circles we have in the world, they don't actually cross all the major cities of the world. So if you're traveling to some major cities in the world, you may decide you may not be allowed to make use of the grade circle because it doesn't cross some of these cities that you're actually heading to. So you make use of a longer route. So these are some of the demerits or disadvantages of grade circles we have. So let's head over to grid lines. Remember I told you that we combine the lines of longitude and latitude to form grid lines. So what is actually a grid line? Now, a grid reference system, or you can call it a grid line, is actually composed of vertical and horizontal lines drawn on a map. So when we actually draw vertical lines of equal dimension and also horizontal lines of equal dimension on a map, we've actually drawn a grid line. And we actually make use of this grid reference system or grid lines to find the exact position of a particular feature or a particular place on a map. And we also apply it whenever we are carrying out map enlargement and map reduction. And the vertical lines are called eastings, while the horizontal lines are called northings. Now, why do we call the vertical lines easting? We call the vertical line easting because it moves from the value 0 down to the eastern side of the map. So we read it on the positive x-axis, while the northings are horizontal lines that are drawn upwards till you get to the north. So the vertical lines, we call them easting, and the horizontal lines are called what? Are called northings. And when we combine these easting and northings, we have either a 6-figure grid system or a 4-figure reference, system. So let's look at an example. Now, this is an example of a grid reference system or a grid line. As you can see, we have the northings. Now, these horizontal lines, which is 53, 54, 55, 56, 57, these horizontal lines are actually called northings. Then the vertical lines that are going to the right, that is from the left to the right, they're actually called eastings. So if we have 25 here, we have 26, 27, 28, 29, 30, and they are being projected towards the eastern part of the diagram. So we call them eastings. So let's look at an example of how we can use this. Remember I said that we have the 6-figure grid system and the 4-figure grid system. Now, we use the 4-figure grid system whenever the values of the grid lines are in whole numbers, like what we have here. And also, we use the 6-figure grid system whenever we're looking for a place with a place on a globe and the grid value contains decimal. So, like this, let's use this as an example. This is a kind of location that we make use of the 6-figure grid system. So we have the purple dot, sorry, the pink dot and the orange dot. Now the pink dot is found in terms of northings, is found between 7 and 8, so we say 7.5. And then in terms of easting, that is on the x-axis, we have it between 2 and what? And 3. So if it's between 2 and 3, we call it 2.5. And in terms of the y-axis, we have it between 7 and 8. So if it's 2.5 and 7.5, we are going to have 0.02.5 and 0.7.5. I will say it again. We have 0.2.5, then we have 0.7.5. So when we are actually writing the grade line down, we are going to write 0.25075. That means 0.2.5 and 0.7.5. So the grid location of the pink dot is 0.25075. Then for the red dot, we have it on the x-axis, that is the easting, between 7 and 8, and on the northings we have it between 2 and 3. So we are going to call it what? 0.7.5 and 0.2.5. So it's going to be 0.75025. Now, if these dots are actually located at the point where we have the whole numbers, we are going to make use of the 4-figure grid system. So we are going to say 0.7, if it's on this point where we have 7 and 2, here on this point, we are going to say it as 0.702. That is the 4-figure grid system. So that's actually how to use the grid system whenever we're locating a place. So this is an example again where we have A, and A is between 15 and 16 on the horizontal side, that's the x-axis or the easting. Then in terms of the northing is at 24. So we make use of the 6-figure grid system here, but in this time 24, that is on the vertical side, that is the northing, we are going to have 24.0. So the reference point will be what? 15, 155 and 240. So it will be 155240. So that will give us the what? The grade point of the location called A. So let's look at time zones, the time zones we have on the globe. So the first type of time zone that we are actually familiar with is called the local time. Now, when I say local time, I'm actually talking about the time we experience or observe whenever we move from one degree to the next degree of longitude on the Earth's surface. Now, this is what it means. We have 180 degrees east and 180 degrees west on the lines of longitude. So for every 1 degree of longitude you move, you've actually crossed from one local time to another local time. So local time is based on a particular degree. That's why if you go to a particular place, or let's say Nigeria, we have different local time. And to get the number of local times we have in Nigeria, you simply subtract 3 degrees east from 15 degrees east, because Nigeria is on longitude 3 degrees east and 15 degrees east. So when you do that, we are going to have 12 degrees east. So we will definitely have 12 different approximately 12 different local time in Nigeria. So every location or every degree of longitude on the Earth's surface has its own its own local time. So the local time in Port Harcourt is different from the local time in Lagos. The local time in Lagos is different from the local time in Taraba State, and the local time possibly in Ibadan is different from the local time in Plateau State. Now that's for the local time. Then we have what they call standard time. Now we actually make use of standard time to avoid confusion created by the local time. Now the standard time is the acceptable or accepted, or the generally accepted time that is being adopted in a country. So what they do is that they look at the central meridian of that country and take the local time of that central meridian and generalize it as the standard time of the entire country. So what I'm trying to say is that for Nigeria, the standard time of Nigeria is the local time of the central meridian being generalized for the entire time in Nigeria. That's why someone in Lagos if someone in Lagos will say that the time is 7 o'clock, someone in Port Harcourt will also say the time is what, 7 o'clock. It means that they are both what, using the standard time. They are not making use of their local time. They are making use of their what, their standard time. Now, standard time is actually adopted to avoid what, confusion or differences in what, in local time. Now, let's say for instance places like Russia where we have up to 11 time zones. Using a local time will be very, very stressful. So they actually make use of what, a standard time. So that it will very easy, using the time when you move from 1 degree of longitude in that city to the next city in that same country. So that's what the standard what time is. Now, if you look at the screen, we have what standard time zones of the world, like Nigeria. We have Nigeria right here. Then we have the Greenwich Meridian here, and the Greenwich Meridian actually make use of the Greenwich Meridian time, which we are going to look at in this lesson. So as you can see, countries on the left, they have a positive standard time. That's to say that they are behind the Greenwich Meridian. So to get the time of that place with reference to the Greenwich Meridian, we make use of we observe these values +1, +2, +3, +4, +5, and we observe these other values on the right hand side as -1, -2, -3, and so on. So what I'm trying to say is that for Nigeria, if the time is possibly 6 p.m. in UK, their time will be what, 6 p.m. -1, because we are 1 hour what ahead of them. That's why we have what, the +1 and the -1 here, and we have the plus here. So let's look at the next terminology for this lesson. The next terminology is actually called the international date line. Remember I told you about great circles, that longitude 0, which is the Greenwich Meridian, and longitude 180 make a great circle. So international date line is simply longitude 180 degrees east or west of the Greenwich Meridian. Now, it's just a line that is running, from the north to the south pole, and the international date line crosses the Pacific Ocean, and it's in a zigzag format, which we are going to see. Now, why is it drawn in a zigzag format? Now, the international date line is actually drawn in a zigzag format so that some countries found in the Pacific region will not have, multiple or local time in a particular place. So it's drawn in such a way that they will have uniformity in their local time. Now, this is one specific thing about the international date line. When you cross the international date line, you're actually a day ahead or a day behind. So you either gain 24 hours of the day or you lose 24 hours of the day. So that's one of the reasons it's actually in a zigzag format when it's crossing some countries in the Pacific. So if I am actually moving through the Pacific Ocean, that is through the international date line, and I'm going towards the east. Now, the moment I cross the international date line, I will be 24 hours ahead. So if today is Friday, for instance, and I cross the international date line to the eastern part of the globe, that is this direction to my right, it means that I have gone a day ahead. So I will be a day ahead of my previous position. But if I go from the other way around to the west, I am a day behind. So if it's Friday and I go from the east to the west and I cross the international date line, I'll possibly take myself backwards to Thursday. So you lose a day or you gain a day whenever you cross the international date line. So this is an example of the international date line. As you can see, it's in a zigzag format through the Pacific Ocean. You get here and it goes zigzag to avoid crossing this country or island we have here, and it goes zigzag again to avoid cutting most of these countries we have in the Pacific region. We have lots of islands there, like Tango, So this is how it is, and it's at longitude 180 degrees, which is +12 in terms of time zone. So the international date line crosses countries like Tonga, like I previously said, crosses countries like Fiji, countries like Siberia, and even the Alaska, you know, it crosses it too. And then the Siberia part of the northern hemisphere, it crosses it. And then a bit of the Aleutian Islands around that Pacific region, the international dateline also crosses that island. So these places or these countries are actually called the ideal zone. So they are the places where the international dateline cuts through. So we have the Greenwich Meridian time, or you can as well call it the world time. Now, the Greenwich Meridian time is actually the time people living on longitude 0 degrees observe. So the time zone, or will I say the local time of longitude 0 is actually the Greenwich Meridian time, because longitude 0 is the Greenwich Meridian. And one thing about the Greenwich Meridian is that other countries of the world that are not found on that longitude, they actually adjust their time, you know, from the Greenwich Meridian. As we've seen in the previous slide, where we have, you know, we are counting +1, +2, +3, +4, -1, -2, -3, -4. Now that's because the Greenwich Meridian time is like a reference time to other local time on the Earth's surface. So as you move from the Greenwich Meridian to the east, the time is increasing by 4 minutes per degree. Then if you do to the west, the time is decreasing by 4 minutes, 4 minutes, 4 minutes, till you get to the last longitude, which is 180 degrees east and 180 degrees west. So that's the Greenwich Meridian. Now, this is an example of what the Greenwich Meridian is. As you can see, we have it here cited at this point, pinpointed here. That's the UK, the Ghana, Accra, that is Accra of Ghana, and some other countries, you know. So the time here is 0 because they make use of the Greenwich Meridian time. So every other country, you know, away from the Greenwich Meridian will adjust this time to fit that of the GMT. Now let's look at the eastern part of America, USA. As you can see, is on -5. So if the time here in the Greenwich Meridian is 12 p.m., the time here in the eastern part of America is going to be 12 p.m. -5 hours. So we are looking at 7 a.m., you know, to be precise. So that's how the Greenwich Meridian time, you know, works, and it's a generally used type of time we have. So let's look at the differences we have between local time and standard time. Now, local time is actually observed for every degree of longitude, but the standard time of a country is the time that they generally adopt or accept in that country. I remember I told you that you actually take it from from the central meridian of that country. And when we talk about local time, you know, the time changes by every 4 minutes. You know, as you move from here to here, you know, every 4 minutes the time will change when the Earth is rotating. But for the standard time, it's basically 15 degrees of every latitude. So in standard time, we have that 15 degrees is 1 hour. You know, as you move from one time zone to the other time zone. But when you look at local time, it's just 4 hours, 4 minutes. You know, for 1 degree of rotation. So if the Earth rotates 1 degree, you have moved from you've possibly moved from one local time to the next local time. And also, the local time has nothing to do with the Greenwich Meridian time. You know, when you're calculating local time of a place, you are not doing it with reference to the Greenwich Meridian time. You're actually referencing it to longitude 0 to get your value. And also, for the standard time, they make very good use of the Greenwich Meridian time. And if you move from one longitude to another longitude, you know, the local time varies irregularly, you know, as you're progressing. But when you look at that of the standard time, as you move from one zone to another zone, that is, we have 24 zones, the local time, standard time actually covers these 24 time zones we have on the Earth. That is 12 to the east and 12 to the west. So let's look at some questions on the exam guide, and we are going to take a UTME question to be precise. That is a JAMB question from 2011. Let's look for a question in 2011. JAMB. Okay. Let's go to geography 2011. Okay, 2011. We have it here. So this is 2011 we have right here. So let's look for a question, and that should be question number 10. Let's look at question number 10. Now, question number 10 for 2011 JAMB in the ExamGuide app says, an example of a great circle is dash. Remember I told you a great circle is actually the line that divides the earth into two equal halves. So let's look at it. An example is dash. A, the equator. B, the earth. C, latitude 66.5 degrees. D, latitude 23.5 degrees. So if you weigh the options given, you see that option D is wrong, because latitude 23.5 degrees is actually a small circle, because the midpoint does not get to the center of the earth. If same as latitude 66.5, then if you look at the earth is the earth, and it's made up of different great circles. So the answer is the equator. The equator is an example of what? Of a great circle. So let's also look at let's go to the SSCE exam guide and look at a question from 2020. So let's look at a question from 2020 geography. So this is the exam guide for SSCE. So let's look at question number 28. Now, question number 28 says, how many standard time zones will country with a longitudinal extent of 165 degrees have? So we have the longitudinal extent as what? 165 degrees. That is the longitudinal difference. So if you recall, we said that 1 hour is equivalent to 15 what? Degrees. So if 15 degrees is 1 hour, now the question they are trying to ask is 165 degrees will be what? So to get that answer, all you simply need to do is that you reference this with what? With 1 hour 15 degrees. So to get the time zones, you're going to divide 165 degrees by 15 degrees. You know, if 1 hour is 15 degrees, that means to get the number of hours or time zone, you're going to divide this by what? By 15. And when you do that, you're going to get what? 11. So option B is the what? The right answer. So 165 divided by 15 degrees will give us what? 11. So it definitely means that they have what? Approximately what? 11 time zones in such a particular place. So far in today's lesson, we've looked at the differences and similarities between latitude and longitude. We've looked at great circles. We've looked at grid reference system. And we've also looked at different terminologies like the international date line and the Greenwich Meridian time and local time. So with that, we've come to the end of today's lesson. Thank you for participating in today's class. You can practice more questions using the ExamGuide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It's a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the videos to people that will benefit from it.